Greetings everyone, Dr.Mungli here. In my previous video, I have explained about carnitine shuttle mechanism to transport long chain fatty acids into mitochondrial matrix, and also I have a video on beta oxidation of fatty acids. The links for both the videos are given in the description below. In this video, I will be explaining you in brief and in simple way about regulation of fatty acid oxidation. Now the fatty acid oxidation regulation, it all revolves around concentration of malonyl-CoA. If you need to remember about something about regulation of fatty acid oxidation, you got to remember about malonyl-CoA. That's the central molecule in regulation of fatty acid oxidation. Let me explain you in a simple way how exactly this malonyl-CoA controls fatty acid oxidation in mitochondria. Now note that the free fatty acids which will be coming from adipose tissue, so they will get into the cytoplasm. In the cytoplasm, free fatty acids are activated into their active form, that is fatty acyl-CoA, and this job will be done by fatty acyl-CoA synthetase enzyme. All that I have explained this in carnitine shuttle mechanism. Now the fatty acyl-CoA, so it will get into intermembrane space, and in the intermembrane space, fatty acyl-CoA is converted into fatty acyl-carnitine with the addition of carnitine done by CPT1 or CAT1 enzyme. Now this CPT1 here, so this particular enzyme I am talking about, CPT1. So the CPT1 is carnitine palmitoyl transferase 1, which is also referred as carnitine acyl transferase 1. Carnitine palmitoyl transferase 1 or carnitine acyl transferase 1, which is located over the outer mitochondrial membrane, is responsible for converting fatty acyl-CoA into fatty acyl-carnitine. And this fatty acyl-carnitine, it will be transported into the mitochondrial matrix by carnitine acyl-carnitine translocase enzyme. And this fatty acyl-carnitine in the mitochondrial matrix, it will be converted into fatty acyl-CoA and carnitine is released. This job is done by CAT2 enzyme, and that is carnitine acyl transferase 2 enzyme in the mitochondrial matrix. In the inner mitochondrial membrane. Carnitine that is released here, it will come back into the intermembrane space. That's what is carnitine shuttle mechanism to transport fatty acid into mitochondrial matrix. Now, the carnitine palmitoyl transferase 1, which is located over the outer mitochondrial membrane, is the one which regulates that's where the regulation of fatty acid oxidation will go on. Now the malonyl-CoA, how do you get malonyl-CoA? So the malonyl-CoA is the regulatory molecule on carnitine palmitoyl transferase 1 or CAT1. Now first of all, how do you get malonyl-CoA? Now the malonyl-CoA synthesis is going on in the cytoplasm. This will be done by acetyl-CoA carboxylase. So the malonyl-CoA is coming from acetyl-CoA. So acetyl-CoA is carboxylated by acetyl-CoA carboxylase enzyme. Note that insulin will have a positive effect on acetyl-CoA carboxylase because it's an anabolic hormone. Whereas under fasting condition, so glucagon will have a negative effect on acetyl-CoA carboxylase. Now the acetyl-CoA which is forming malonyl-CoA, so the malonyl-CoA will go into fatty acid synthase complex and ultimately converted to palmitate. That's a 16 carbon fatty acid. Now the thing here is, when the person is in well-fed condition, you all know there will be increase in insulin. And this insulin will keep acetyl-CoA carboxylase active, and activated acetyl-CoA carboxylase will increase the concentration of malonyl-CoA. Now whenever the malonyl-CoA in the cytoplasm is high, and that malonyl-CoA will have a negative effect on CPT1 or CAT1 enzyme. So the high concentration of malonyl-CoA in the cytoplasm will keep CPT1 or CAT1 inactive, thereby fatty acyl CoA is not converted into fatty acyl carnitine. Thereby, fatty acyl carnitine is not transported into the mitochondrial matrix for beta oxidation process. It means the beta oxidation, it all depends on the activity of carnitine shuttle mechanism. So since carnitine shuttle mechanism needs activity of CPT1 or CAT1, and this CPT1 and CAT1, it is inhibited by high concentration of malonyl CoA under well-fed condition. So under well-fed condition, you have plenty of insulin. Insulin keeps acetyl-CoA carboxylase active, and that acetyl-CoA carboxylase increases malonyl CoA concentration, and that malonyl CoA will inhibit CPT1 or CAT1, thereby fatty acid that is synthesized in the cytoplasm, it is not going into mitochondrial matrix for beta oxidation process. This is how beta oxidation is prevented, by preventing transport of fatty acid from cytoplasm into the mitochondrial matrix. That is all done because of high concentration of malonyl CoA. Now let's see under fasting condition how this thing is reversed, or how the fatty acid oxidation is activated. So under fasting condition, as you all know, glucagon is increased, and this glucagon is going to have a negative effect on acetyl-CoA carboxylase. And because of this, what happens? So the acetyl-CoA is not entirely converted into malonyl CoA, so the concentration of malonyl CoA decreases. When the concentration of malonyl CoA decreases under the influence of glucagon, so the malonyl CoA's negative effect on CPT1 or CAT1 is now taken off, means it is not there. Because malonyl CoA concentration is decreased, because of the decrease in malonyl CoA concentration, so the malonyl CoA's negative effect on CPT1 or CAT1 is now not there. Because of this, the fatty acyl CoA which is there in the cytoplasm, and that will be transported into the mitochondrial matrix, and beta oxidation is made possible. So this is how the fatty acid oxidation is activated, because of the low concentration of malonyl CoA under fasting condition, and that happens under the influence of glucagon. And also, as you might be knowing, that glucagon will have a lipolysis effect on adipose tissue, and it will bring free fatty acids from adipose tissue. So free fatty acid floods into cytoplasm, and those free fatty acids are transported into the mitochondrial matrix through carnitine shuttle mechanism, and ultimately they will undergo beta oxidation. So it all comes down to the concentration of malonyl CoA. So the malonyl CoA concentration, if it is more, so it means CPT1 and CAT1, CPT1 or CAT1 is inactive. If the malonyl CoA concentration is less, CPT1 and CAT1, they are active, and they will allow fatty acids into the mitochondrial matrix for beta oxidation process. I hope you understood. You see the regulation of beta oxidation, it is all over CPT1 or CAT1 or outer mitochondrial membrane, and that is controlled by concentration of malonyl CoA. That's all about regulation of fatty acid oxidation. All you got to remember is malonyl CoA and CPT1. When the malonyl CoA concentration is more, CPT1 is kept inactive. When the malonyl CoA concentration is less, CPT is kept active. So insulin is going to maintains high concentration of malonyl CoA, thereby it is going to keep CPT1 inactive, thereby beta oxidation is prevented, whereas glucagon is going to keep malonyl CoA concentration less, thereby its negative effect on CPT1 is taken off, thereby beta oxidation is activated. Thank you again for watching, and see you in my next video. Till then, take care.